Hello everyone, I just wanted to get on here today and make a little quick video about synthetic division. If you're in my class, and it goes along with some of our lessons in chapter 5, beginning with section 5.5. And synthetic division is another way to divide polynomials other than long division. I know that long division can be somewhat challenging and confusing for some of us, but synthetic division is another way to do that so that we can look at it and get our answers to division problems, which can help us factor polynomials and can also find the zeros of a polynomial function. So let's just start by dividing a few polynomials. I have a few examples for us to do really quickly today. The first one is x to the third power minus 2x squared minus 40x minus 64. And I'm going to divide that polynomial by the binomial x minus 8. So the first thing I want to do is I want to get a zero of this polynomial from this binomial that we're dividing the polynomial by. And the way we do that is we just come over to the side and set that binomial equal to 0. And we'll add the 8 to both sides. And so x equals 8 is a solution to the polynomial. That means that this polynomial graph will cross the x-axis at 8 on the x-axis. So what you're going to do after you get the 0 by setting the divisor into equal to 0, you're going to take that 8 and you're going to put it over here in a corner. And then you're going to take your coefficients of your long polynomial and you're going to space those out. So the first leading coefficient is a 1. And then on the x squared, we have a negative 2. With the x, we have a negative 40. And our constant term is a negative 60. So just kind of space those out and then skip a space and draw a line. And then what we're going to do when we do our synthetic division is we're going to first bring the 1 down. So whatever is on the bottom row, we will multiply by the 8 up in the top left corner. So we bring the 1 down and we say 8 times 1 equals 8. And you're going to put that 8 right there. And then you're going to add down the column. So negative 2 plus 8 equals 6. Okay, so now you're going to take your bottom row number and multiply it times your corner. So 8 times 6 is 48. And you're going to write the 48 right here. And then you're going to add down the column. So negative 40 plus 48 is a positive 8. And then you're going to multiply again. Bottom row times the corner. 8 times 8 is 64. And then we add those and we get 0. Well, this bottom corner right here is your remainder. So we have a remainder of 0 when we divide this polynomial by x minus 8. Now for your polynomial at the bottom, you're going to go down 1 degree. So this is a third degree polynomial. So when we divided this at the bottom with no remainder, it's going to be a square. So it's going to be 1x squared plus 6x plus 8. So when we divide it, technically we get the trinomial x squared plus 6x plus 8. So if we were just dividing, this would be our answer. They can ask us quite a few things about this. They might ask you to find all the factors for this polynomial. So if that's the case, we already know that x minus 8 is a factor. So to get the second and the third factor, what we would do is factor this trinomial. So we want to know what multiplies to get 8 and adds to get 6. And those two factors are 4 and 2. And so our binomial factors are x plus 4 times x plus 2 for that trinomial. And don't forget the x minus 8 from the very beginning. So all three of these is the factors for the polynomial x to the third minus 2x squared minus 40x minus 64. Now, if they ask you to find all the factors, that's what you would do. If they ask for all of the solutions or all of the zeros or all the roots for the polynomial, what you'll do is you'll take all of those factors and you will set them each equal to 0. So you'll say x minus 8 equals 0, x plus 4 equals 0, and x plus 2 equals 0. So your solution would be x equals 8, x equals negative 4, and x equals negative 2. So if it asks for the solutions, then your solutions are 8, negative 4, and negative 2. Let's do one more example for synthetic division. All right, this time let's do the polynomial x to the third power minus 10x squared plus 19x plus 30. And this time we want to divide by the binomial x minus 6. Okay, so the first thing we want to do is find the 0 or the root for this binomial here. So you'd come over to the side and say x minus 6 equals 0. Well, you would add 6 to both sides, so x equals 6. So that's your number that goes in your top left corner for your setting up for your synthetic division. Then you're going to take all of your coefficients for your polynomial. The leading term is a 1, and you have a negative 10, and you have a 19, and then you have a 30. Draw your line, skip a space and draw your line. If you want to go ahead and put your little box for your remainder over here, you can, because it will be on the bottom right. All right, remember that we drag down our leading coefficient. And then whatever's on the bottom row, we multiply by the left corner. So 6 times 1 is 6. We write that down here. And then we add down the column. So negative 10 plus 6 is 4. And then we multiply 6 times 4. And we get, I'm sorry, that's negative 4. 6 times negative 4 is negative 24. I'll just put a 5. I'm completely tearing up this problem. It's okay. We all make mistakes. So 19 minus 24 is negative 5. And then multiply the times the corner. 6 times negative 5 is negative 30. And 30 minus 30 equals 0. So again, we drop at a degree. We started with an x to the third. So this trinomial that we're left with will be 1x squared minus 4x minus 5. So if we were just dividing, that would be our answer. If they want to know all the factors, then we would make a table with this trinomial, multiply to get negative 5 and add to get negative 4. Well, that would have to be a negative 5 and a positive 1. So that would be an x minus 5 and x minus 1. Sorry, x plus 1. And don't forget x minus 6 is also a factor because it came out evenly when we divided. So if it wants the factors, or for you to factor it completely, that would be x minus 6, x minus 5, and x plus 1. If it's looking for the zeros or the solutions or the roots or the x-intercepts or whatever they're calling it, you will have to take all of those and set them equal to 0. So then you would have x equals positive 6, x equals positive 5, and x equals negative 1. So this polynomial will be crossing the x-axis at these 3 places. So hopefully that'll help you see a few more examples of synthetic division. Good luck.